Hi guys, it's Mrs. Tucker. I wanted to give you guys just a little help with your homework tonight. This applications of volumes worksheet. There's a few problems on here that I just want to get you pointed in the right direction. Okay, so take out that worksheet and I'll let you use a calculator if you're showing me all the work. All right? You know what I want you to show me. I want you to write down the names of the shapes. I want you to write down the formulas and then plug the numbers in. After you do that, then you can use the calculator. First one I want to talk about is this one. It says Mr. McAllister wants to pack the small box shown below inside the big box. What is the volume of the space outside the small box but within the large box? So what they're going to do is they're going to take this one and put it inside of this one. So you've got this smaller box that's set inside this bigger box, kind of like this. Okay, the smaller box is put inside the bigger box. They want to know the amount of space that's inside the bigger box but outside the smaller one. So what you're going to do is you're going to find the volume of this big box, you're going to find the volume of the small box, and then what's the last step? Yeah, if you want to find the volume inside the big box that's not occupied by the small box, you got to take the volume of the big and subtract the volume of the small. And then what's left is the volume of the air in between the two boxes. Okay? How do you find the volume? Well, first of all, name the shapes. They're both rectangular prisms. I insist you write that down. And now you have to come up with a formula. This is where you're going to pull out your formula chart. Wow, looky, mysteriously my formula chart just appeared. You're going to go in there, you're going to find volume, you're going to find a prism, and then you're going to find the rectangular prism right there. So write that down. Volume equals length times width times height. Here's your length, here's your width, here's your height on the big one. Here's your length, here's your width, here's your height on the small one. Plug in those numbers, calculate both volumes, and subtract. On this one, Mark packs dirt into 4 cube-shaped containers. Cubes are a type of rectangular prism. Okay, I insist you write that down. I insist you write that down. Each container has side lengths of this, so your length, your width, and your height are those. How many cubic meters of dirt does Mark pack into all 4 containers? Once you plug in the numbers for your length, your width, and your height, that gives you the volume for one. You got to turn around and multiply that answer by 4. Okay? That was for number 5. Let's see. What shape is a funnel? Okay, they want to know, they say that Mr. Pham used a funnel to pour gasoline into a lawnmower. The funnel he used has a diameter of this. If D equals 10, what does your radius equal? And it's this many centimeters long. That's going to be the height of your funnel. It says how many cubic centimeters does the funnel hold? If you see the word hold, fill, fill up, or cubic units of any kind, they're asking you for volume. So now you just need to find a formula. Let's see, volume of a cone. You're going to use that formula right there. Pi, radius squared, height divided by 3. Don't forget to divide by 3. All right. Let's look at this sheet right here. Let's see which ones you might struggle with here. Ellen's greenhouse is in the shape of a hemisphere. Okay, that's the reason I pulled this one up. A hemisphere looks kind of like this, sort of like that, and here's the diameter. Isn't that half of a sphere? So they say the diameter diameter equals 18 feet. What's the approximate volume of the gas in the greenhouse? You got to take that formula for what's the shape? Well, it's part of a sphere. It's half of a sphere. You got to take the formula for volume of a sphere, which is this one right here. 4 times pi times radius cubed, which means radius times radius times radius, divided by 3. When you get that answer, that's for a full sphere. You only have half of a sphere. So you got to take that answer and divide it by 2. Okay? Next problem. What is the difference in the volumes between the two shapes? Name the shape. Find a volume formula. Name the shape. Find a volume formula. They say, what's the difference in the volumes? You're going to find the volumes of both of these, and then you're going to, last step, subtract to find the difference. Where are you going to find those volume formulas? Right here. Here's the volume formula for the rectangular prism. For the cylinder, here's the volume for the cylinder. Those formula charts really do come in handy, don't they? Okay, a large Pringles potato chip can, and let me go back to that one. You're going to have to change the diameter here. Here it says the diameter is 2 inches. What are you going to use for the radius? Okay, don't forget that. All right, we've got a Pringles can. Pringles can is a cylinder. It's really long. It has a diameter of 8 centimeters and a height of 23 centimeters. Let's see here. A Slim Jim smoked snack can has the same diameter and a height that is 6 centimeters less than the height of a large Pringles can. So here's the Slim Jim's can. It's also a cylinder. These are both cylinders. Write that down. The Slim Jim can has the same diameter. So right here, the diameter equals what? Yep, that's 8 centimeters. But it says its height is 6 centimeters less than the height of the large Pringles can. So this height right here is 23 subtract 6, which equals what? And then they want to know what's the difference in the volumes of the two cans. Well, now I need a volume formula. I need to calculate the volume of the Pringles can. I need to calculate the volume of the Slim Jim's can. And difference means I need to subtract. I need a formula. They are both cylinders. There's your formula for the cylinders. Don't forget, you need to convert the diameter into a radius. If your diameter is 8, what's your radius? That's right. Calculate the volume of both and then subtract. All right, a cement truck arrives at a construction site with 432 cubic feet of cement. If the driveway being constructed is 18 feet across, which set of dimensions cannot be the width and the height of the driveway? Okay, we know we've got a driveway, and it's probably pretty long, something like that. And we know that the driveway is 18 feet across. Right here, from here to here is 18 feet across. They want to know, when you take 18 and multiply by the height and multiply by the length, which one of these sets of numbers is going to give you that for a volume? So you can just do guess and check. Your volume, well, let's see here. Let's start off with name the shape. It's a prism. Volume equals length times width times height. It's a rectangular prism. Thank you. I heard you. Length times width times height. They gave us a volume of 432 cubic feet. I know it's volume because it's cubic feet. So I'm going to plug in right there, 432 has to equal my length times my height times my width of 18. They want to know which one of these will not give you a volume of this. So plug in a 2 for your length, for your, well, I guess let me undo that. Your height would be 2, your length would be 12, and a width of 18. Does that give you 432? If it is, we're looking for the one that it can't be. So you're looking for the one that is false, that does not give you 432. So I don't know if that works or not. The next one you're going to try is 18 times a height of 2.5 times a height of 9.6. If that does equal 432, that's not the answer. You're looking for the one that does not give you this volume. Okay? Good question. All right, a juice company is considered creating an extra large juice can. Right now, their cans, which are cylinders, this is a great star question. It has a height of 10 inches and a 4-inch diameter. If they want to increase the amount of juice that in each can by 10%, how much will the extra large cans hold? You've got to calculate the volume of this cylinder. Don't forget, you got to change this to a radius. And then you've got to add on 10% more. You've got to add on another 10% more. 10 out of 100 equals the part that we're adding on over our original, whatever this volume is right here. Once you find out what your 10% part is, you're going to add that onto the volume of the can that you already have. This will calculate the amount that's 10% of your current volume. You add that onto your original volume. And you can do that by cross-multiplying here after you calculate the volume of this can. Calculate the volume of this can, it goes right there. Okay? Ooh, that's a good star question. Really hard. They like difficult questions on the STAR test. Okay, next problem. The volume of a pyramid with a square base is that. The height is that. What's the area of the base? It is a pyramid. It's a rectangular pyramid. Okay, I need a formula. Got your formula for rectangular pyramid? That one right there. Let's plug in what we know. They gave us the volume. They say the height is 6 inches. Oops, let me take that out. The height is 6 inches. Wouldn't length times width be the area of the base? Let's just call this right here, let's just call this piece right here the area of your base. That's what you're trying to solve for. Okay? You guys can work that one out. Here is an open-ended question. Let's talk about this one in class because this leads into our next topic. All right, guys, good luck with this. See you in class tomorrow.